Welcome back, Year 8, to the final video, and this week's topic is fractions. I'm going to do a quick review of all the skills you should already know and show you some examples that will help you with the work that you have in your CGP workbook. So quickly going over what a fraction is, we remember that a fraction describes an equal part out of a whole. So if we see in the first one, we've got 3 out of 4 squares in the big square are shaded. So that's 3 out of 4, 3/4 have been shaded. In our next example, we can see 2 out of 4 have been shaded. Now we know we can simplify that to 1/2. We've got one column out of 2 columns shaded. So 2/4 and 1/2. It's a simplified fraction. They're equivalent fractions. We're going to look more at that later. And the last one, we don't have a fraction split into equal parts. So is there anything we can do? Yes. We could split this fraction into equal parts by drawing the same lines across. And we can see that there are now 8 equal-sized triangles and 2 are shaded. So we've got 2 out of 8. We can also imagine that we moved that shaded triangle up into the top corner and we'd have 1 square shaded out of 4 squares. So 2/8 and 1/4, that's simplifying 2/8 to 1/4, they're also equivalent fractions. So to look a bit closer at equivalent fractions, they are fractions that mean the same amount, but they look different. They use different numbers in them. The best example I can give is 1/2 equals 2/4 equals 3/6. That's just like the example we gave. I'm thinking about pizza. If I've got a pizza that's cut into 2 and I'm keeping 1 slice, it might be a bit sloppy to eat, so I'm going to cut it in half again. Now I've got 2 slices out of the 4. Or if I'd cut the whole pizza into 6, if I had half, I'd be getting 3 slices out of the 6. You can see that each one of those fractions represents the same amount of pizza, it's just in different numbers. How we generate them, how we make them, is by multiplying the top and bottom by the same number. Okay. We can see another example. 2/5 is equal to 6/15 because we've multiplied by, that's right, 3. Okay. And we can see an example where they're not equal. I've used the not equal sign. 3/7 does not equal 6/21 because the top half has been multiplied by 2, but the bottom, the denominator, has been multiplied by 3, so they are not equivalent. Now simplifying fractions is exactly the same as finding equivalent fractions, but with equivalent fractions we were multiplying to make both the numerator and the denominator larger. Simplifying is making both the numerator and the denominator smaller. So instead of multiplying, we're going to be needing to be dividing. Now to find out what we need to divide by, we need to look for a common factor. So if we had to simplify 5/15, we'd be thinking, what's the common factor of 5 and 15? Well, we can see that it's 5. So we'd divide them both by 5, and we'd end up with 1/3. So 5/15 is equivalent to 1/3. We've simplified 5/15 to 1/3. I'll give you one more example. If we had to simplify 12/20, we think, what's the common factor of 12 and 20? Okay, I can tell that it's 4. If you only found 2 and you cut them in half to 6/10, that'd be fine, but you'd notice that 6 and 10 have a common factor of 2 and you'd divide them again by 2, which would end up leaving us with 3/5. Okay, so 12/20 simplifies to 6/10 and then again to 3/5. When it says simplify, we always want to simplify it as much as possible, all the way until it won't simplify anymore. A review of mixed numbers and improper fractions. So here we've got 1 whole one and 3/4. That in itself is a mixed number. Now if we counted only the red squares, we would have 1, 2, 3, 4, 5, 6, 7 red squares and 4 make a whole one. We wouldn't write 7 out of 8. We're not saying how many are there. The denominator, the bottom number, tells us how many make a whole. So because we can see we've got 1 whole one and then 3/4 of a second one, then we're saying we've got 1 and 3/4 or 7 pieces when 4 make a whole. So we can see that 1 and 3/4 is a mixed number because it's got a regular number 1 and 3/4 a fraction, whereas 7/4 is an improper fraction because the numerator is bigger. Now here's an example where we're going to change 7/5 into a mixed number. All we need to do, since we know 5 makes a whole one, is count how many 5s will fit into the numerator. So there is 1 5 in a 7 with 2 left over. So we can say that we have one whole group of 5, and 2 left over. The remainder 2 goes on top. The denominator stays 5 because 5 make a whole one. If we were going to go the other way, changing a mixed number into an improper fraction, that should say improper fraction, 2 and 3/5, 2 whole ones and 3/5. We need to know how many pieces would that make. Well, if 5 pieces make a whole one, 2 whole ones, 2 lots of 5, that's 10 pieces for my whole ones, and I've got 3 extra on top, so altogether I've got 13 pieces. How many make a whole one? 5, so it's 13/5. Now we come to adding and subtracting fractions. So we remember the golden rule for adding and subtracting fractions is that we need a common denominator. So when we have one, 3/8 plus 2/8, we can just add the numerators, is 5/8. Works the exact same for subtracting. If we have a common denominator, 4/9 minus 1/9, we can just subtract the numerators. 4 minus 1 is 3. 3/9 can be simplified because we have a common factor of 3 in both of them, so we get a third. Now, if we don't have a common denominator, in this example 4/5 minus a third, we need to make one. We can use equivalent fractions to make both of these fractions have the same denominator. What we do is we look for a common multiple of 5 and 3. We know that the common multiple of 5 and 3 is 15. If you had more difficult or larger numbers, you could write out the times tables and then circle the multiple that's the same in both. So 4/5 to become 15ths is being multiplied by 3, and 4 times 3 is 12. 1/3 to become 15ths is being multiplied by 5, so we'd have 5 out of 15. So we can now rewrite the question with both fractions having a denominator of 15. So we'd get 12/15ths minus 5/15ths leaves us with 7/15ths. Now can we simplify 7/15ths? No, we can't. When we look at multiplying fractions, we simply need to multiply the numerators and multiply the denominators. You could imagine it was written like this, 3 times 2 over 4 times 5. So when we write them out, we get 6/20ths. We notice that there is a common factor of 6 and 20, which is 2, so we can divide it and get 3/10 is our simplified answer. Now sometimes we might get a question that has a mixed number in it. The way to work out a mixed number is to turn it to an improper fraction. So 1 and 1/5, we know that the whole one would have 5 pieces, and with a spare piece we should get 6/5. So I've multiplied 1 times 5 to get the 5 pieces plus the extra one, 6/5. Now that we've got 6/5, we can multiply the numerators and multiply the denominators. So we end up with 12/15ths. We can simplify that as well, as we see there's a common factor of 3. So we divide 12 by 3 and get 4, and 15 by 3 and get 5. So now we come to dividing fractions. Depending on who your maths teacher is, there are 2 ways to work out dividing fractions. I'm going to quickly show both methods. I want you to stick with the one that your teacher has taught you. So for the question 1/4 divided by 3/8, the first method would be making a common denominator. So we could look that 1/4 and 3/8, we could find there's a common multiple of 8. So we could turn 1/4 into 2/8. Then we'd rewrite the question as 2/8 divided by 3/8. Just like multiplying, we would divide the numerator by the numerator and the denominator by the denominator. So 2 divided by 3 over 8 divided by 8. Well, 8 divided by 8 is just 1, so our answer would end up being 2 divided by 3. Since we want a fraction as our final answer, the easiest way to write 2 divided by 3 as a fraction is 2 over 3, or 2/3. The second method is the keep, flip, and change method. So what we'd want to do is keep the first fraction, 1/4. We'd want to flip the second fraction. Instead of 3/8, we'd want it to be 8/3. And we'd want to change the divide sign to a times. So we'd end up with timesing 1/4 times 8/3. And as we multiply across, we'd end up with 8/12. Now we do need to simplify this because 8 and 12 have a common factor of 4. So if we divide them both by 4, we end up with 2/3. And of course we get the same answer, because it doesn't matter which method you use, there's only one correct answer. What you need to do now is get to your workbook, and in the higher book it's page 14, and in the foundation book it's page 10. Have a look at the examples and then try the questions yourself. Do remember to take a picture of it and email it to your maths teacher. They'd love to see it, they'd love to mark it and give you some feedback on it. If you finish that and you need a little bit more work to do, head over to corbettmaths.com/contents, and there are lots of questions to have a try. Fractions addition with same denominators with different denominators, the equivalent fractions, fractions of an amount, dividing fractions and multiplying fractions. All of those will have tons of questions that you can try. Thank you for working so hard at your maths,